Okay, so in this module we're going to talk about the ScreenBlanker. As you all know, computers have monitors. In the old days you needed either turn them off or have something change on the screen or else you'd get burn-in. With modern LCDs it's not a requirement anymore, but the idea of a blanker and having something fun on the screen is still quite popular. From matrix letters falling down to photos to dictionaries and words on the Mac. There's lots of options. But on the Amiga we have less. So the point of this module and in this particular discussion is to introduce to the ScreenBlanker framework. And the reason why I think this is a great introduction, because most of the heavy lifting exists in examples already, so you don't actually have to do too much work to actually start impacting things on the system. And then building a ScreenBlanker for myself has been rather fun. Be able to create my favorite blankers from AmigaOS 3, download them off the AmiNet with the source, and then be able to port them to OS 4 was a lot of fun. And then building a blanker from the ground up to do photos. So I can finally show photos on my screen without using something like Commander or a third application. Both of these blankers are going to be released to OS 4 Depot. If you're watching this video in the past, you can go to OS 4 Depot and download them. Just search for blanker and you should be able to find them. The people in the room have distributed the files. Everyone here should be able to build the project. I'm going to start off with a quick overview of the blanker system. From a system perspective, put the blanker installed, show it running, and then walk through the various program aspects, the preferences that created. And then what we're going to do is dive into the code, walk through some of the modules that are required, with the end result that by the end of the seminar you'll be able to see the code, make some changes, change the colors, change some of the parameters, or even take the block of code that's actually writing to the screen, tear it out and put something in its place. Even if it's something simple, just to show that you can do it and build a blanker. One of the first things I want to mention about the blanker is that it's actually a system library, which is a little different from most other things. What you're building when you create an Amiga blanker is a system library that's called by the blanker engine. So this is very different from a traditional program where you would run it as part of an inbound request or the user action that would create it. It's designed to interact with another part of the system. And the reason why it does that is because the ScreenBlanker engine is paying attention to the timing, the user's input, it's paying attention to the monitor status, and it's handling a lot of that for you, so you don't have to deal with it. Which is another great thing about this particular subsystem, is it's easy to work with. You can just scribble on the screen is what you have to worry about. I'm going to go through the flow very quickly, and then I'm going to jump to the actual operating system, and we'll start looking at we'll move the blanker into place, and we'll examine what it does and the various functions, and then we'll jump into code a bit further. So the basic flow of the ScreenBlanker, the ScreenBlanker engine decides it's time to blank the screen. It engages the blanker module. There's a couple parameters here. You can set it to randomly pick one from a list. You can have a single one there. You can have none, in which case it wouldn't do anything. It then loads that blanker module and begins its execution. Some data is passed from the ScreenBlanker engine that you can read through various structures as the blanker is executing. The blanker module then creates its own screen and window to draw on, scribble, and then, or it uses the preview error depending on how it's being viewed. And we'll walk through how that actually happens in the code. It's very simple. And then the business happens where the ScreenBlanker is doing its work with the supplied raster report, again, preview or full screen, and then it blanks until it receives a signal. You can do whatever else you want to do inside that. You could have user interaction to some degree, although you have to hack pretty deeply. But the idea is to put something on the screen to make it pretty and to make your machine a little bit more personally enjoyable. So I'm going to minimize this window. Knock these guys out of the way real quick. Start by opening the preferences window and start up the ScreenBlanker engine itself. Here you see the number of blanker modules are already installed. On the left side you have active modules, and on the right side you have inactive. You can move them back and forth by simply clicking on them. Under miscellaneous you can choose the order, whether it's sequential, and then you can also set the timing between how it moves across them. So in this case we're dealing with a blankers called IFS. IFS is a mathematical function. It's referred to as the scrawls of God. I just love the way that it looks, and so I wanted it on OS 4. So I ported it from an OS 3 blanker where I first encountered it. So in this case, I'm going to go to the blanker directory. The way this source code is structured, I have two folders: the blanker, which is where the execute was compiled into, and then the source code, cd to blanker. And then I have a couple of files here. So I'm just going to copy the IFS blanker and the info file to sys, utilities, and blankers. And now this module is installed. And if we open this up to restart that application in order for it to rescan, there should now be an IFS. And you'll notice it's beginning to draw on the preview window. So by clicking on it, it's actually loaded that binary that we're going to create. It's gone through the functions and said this is a preview. It's passed to the blanker engine the size of this little window, which is 160 by 200. Got that memorized. This little window, and starts doing its functions. So for instance, in a photo case, the photos would get scaled down if you wanted to, or not, depending on what you're doing. You can decide not to handle anything there. Just let it go and not have a preview for your blanker if you'd like. There's a test full screen button that you can click. Very active mouse over here. And so you can see it drawing on the screen. There's something about the patterns that it produces that I just find absolutely mesmerizing. These are actually lower colored. One of the things I wanted to do in the future for the blanker is manipulate the section that chooses the color so it always chose a vivid bright color, but it's something I haven't implemented yet. But as you can see, it's kind of fun to look at. It's a nice one. Looking back at the blanker module, we have the version information and the author information. I'll show how that gets set in the program. And then we have the module preferences. This is all Boopsy, GAD tools or whatever, standard Amiga UI stuff. And the framework has all of the calls already there. So the way I started is I downloaded an example browser by Renee Olson. Blanker, sorry. Example of Blanker. And just started changing the names of functions, figured out how to add the pieces that I needed. These are all drop-downs. These are all sliders. And these actually are designed to interact with the program directly and actually change the rendering as it occurs. There's a few little issues that I know about in terms of the way the code works. So for example, the redraw time of this window for preview is a lot longer than it is on the full screen. I don't know why, but it works. So I'm not going to get too upset. Because no one cares. It's the preview. So anyway, you have the controls here. You have the screen selection at the top. When you save these, it's actually, there's a bit of code that we'll go through that saves them to an XML overall ScreenBlanker prefs information. So when you're moving these blankers back and forth, like flower to here, it's throwing a switch in an XML file for ScreenBlanker. That's how it disables it now, as opposed to copying it out of the folder. And we'll talk about how to interact with that section as well. Good thing about this, it touches a number of libraries, it has some serial debug that we'll look at. So it encompasses a fair amount of the system. So I'm going to go ahead and hit save for this. And then I'm going to close the preferences, and we'll open up our code bench. Actually, no, I take it back. We're going to start with an overview of the functions. So, we'll use code bench because it has this nice function tool somewhere in here. So I'm going to open up the code bench window. It has a number of different pieces. We haven't really talked too much about the code bench IDE. But one of the modules that it has is the quick link window. And here I'm on the header file. So I'm going to click over to the C file. Steve Sully is a Luddite. He said that in public because he doesn't have quick to front turned on, which is really annoying if you're used to it. Qualifier. Yay! Now
Where did you copy the blanker to?
The question was where to copy the blanker to. System, utilities, blankers. And they always stay in that directory whether they're enabled or not. Okay, so I'm going to try to go back here, bring up our quick link menu. The reason why I'm using this quick link menu is it actually has a list of all of the functions that exist in our C code. And I want to use this to sort of expose CodeBench as well, the IDE we've been talking about. So if I click on one of these functions, it'll jump in the code to the beginning of that particular function. So it's a very nice tool for moving around inside the C project. As you can see from this list over here, there's a fair number of functions that are required. The best part about the ScreenBlanker is you don't have to worry about most of them, and half of the ones that are left, you only have to do a little bit with. So the names are also pretty well defined. Start is the initial entry point into the program. There's an initialization manager because it is a library. And the example already covers all of this work. You don't have to touch this to create a new blanker, which is the great part. Obtain, release, these are all library functionality. And then we're getting into the blanker aspects, release, expunge, clone, get, and set. And going back to the tutorial, I put some information here about what each one of those things do. And then I also have a list of the things that we need to worry about, the ones that you really need to touch in order to make changes. And that's the blanker, get and set, opening and closing the libraries. If you make any changes and need system libraries, you need to make sure they're in both places. The GUI functionality, the setting handling, and then the rendering aspect. The way I think about it, the rendering aspect is sort of the business of the blanker. It's what the C code that draws what's going to happen. And then integral to all of this is also a blanker data header file. And this is a very, very handy thing because, and this is the one for this particular project, it stores for us all of our functions so that we can always address them by the structure, which in case is BD. So if I ever need to read the functions or any of these settings, all of the GUI calls, it's all stored in that main structure. Pretty straightforward once you get the hang of it. So, going back to here. So the initialization part, again, the ScreenBlanker engine is going to do the calling of the code. You just need to make sure your libraries are opening. So I put a little example here, and this will be posted to the tutorial page for future reference. We'll dive into the code in just a minute. Open your libraries. The GUI portion, again, is very standard GUI stuff. It's a lot of code if you're not familiar with it, but we can show that you can make simple changes and then how those reflect back. The preferences management, which is another great part of the blanker engine, and then the rendering bit, which is where it draws on the screen. So jumping into the actual blanker itself, starting with the initialization, I'm going to go into the open libraries call here, and as you can see, the particular style might be a little bit different from the code you're used to, but in general, here I am creating the iApplication interface for iApplication calls. So if I double click here and hit the search gadget, I can do next, next again. So we're actually not even using it, so I could actually pull that one. There's some additional things in here that might not be necessary apparently. Let's pick a better one. Chooser base, here we go. The iChooser. I think that'll be there. So here we go. So here's where we're actually here's where we're actually using that particular library call. So we're using this structure of the name of the library as basically a structure, and then the member happens to be the chooser. With CodeBench, you get the pop-ups with the system information. The other great thing is if you hold the Shift key and click twice on any of the functions, I should say most of the functions, it'll get you to the auto dock. So it'll immediately bring that up in another tab, which is fantastic when you're working with some of the more complex ones and want to understand what the various options are. So we talked a little bit about the libraries, making the GUI. Here's all of the code that generated the GUI that we saw. You can see here this label text. This is what the user is actually going to see. We'll spend a little more time in reaction tomorrow. Again, all of these additional settings don't need to be done initially. If you want to make changes, you can actually leave the GUI piece alone and just don't break those things and hard code all the values for whatever you want to do. So if you just want to change the screen to a different color every few seconds, we can very easily implement that without having to touch the rest of the Blanker structure and the Blanker program until you want to make those changes to make it more robust. Which is what I did initially and added these things. So it was easy to prototype and work with. A few crashes here and there, but it wasn't too bad. So it also has all the function for dealing with the GUIs. Again, we'll discuss more of that tomorrow. I'm going to jump into the Blanker get, because I think this is some great code. This is the functions to set values into that XML file I was talking about. So for example, the library is ipref objects, and one of the members here is set object for key. You can see it takes the dictionary word, the object, and the key. I'm sorry, the dictionary pointer, sorry, the object and the key. So if we look back at the code, what that's telling me is that this is the dictionary object. As you can see from slightly above, it's creating it. And then the type is pref's number, and this is an interesting point. The different types of values, because you know everything's typed in C, are going to be stored as a different type. So here it's a pref number, it could be a string. The different preferences are going to be, you need to make sure the code is set up. In this one it's all numbers, so that's the only example that's in this particular Blanker. And then we have the, let me open this guy up. This one takes the pref object, which was the object file, and then it's a tag list approach. Going back to the C code, this is a type that's defined in the blanker.h. This is the actual function, and it's being, and this is the end of the tag. So the key in this case is functions, and the data that's being stored is the Blanker data functions reference to the structure. So focusing on this particular thing, the rendering code has a variable for that. It controls the part of the mathematics. Iterations is probably a little easier to describe. It controls the number of iterations through the loop as it calculates the mathematical pattern to put the dots on the screen. So what I'm doing here is I'm storing in the preferences engine the iterations number that comes from this structure, which is part of the blanker.h. So if we search for this guy, you can see here that the default, because this function is probably default. Oh, this is Blanker set. So it's setting the message data to 252 when you reset the GUI to default. Searching for that again. Here you can see the UI code that's engaged. So here, if the slider level changes, it takes the value that was changed and sticks it in that particular pointer so that everywhere else can reference it. We'll jump again to the math part. Let's see, this is the default. Okay. So here you can see in my local function, I set the length of the iterations to the BD iteration function. So just sort of running through this. The idea is that when you have a parameter, do you show it to the user? Do you need to save it? Do you need to retrieve it? And the way this example is set up, it has all of those functions covered. So you can really think about, okay, if I was just getting started, I could just say length equals 200. And now I can build whatever I want. All that pref stuff doesn't actually do anything anymore because it's not controlling that variable. But if you want something controlled, you can use the engine to do it. If you're familiar with like a key value store, that's what that engine is. I have a key, and then I have a value associated with the key. So if I want to get that data back, I give the system the key, and it gives me the value, and then I can save it throughout. So, talked a little about the settings. The way the blanker works is we get a blanker blank. So this is sort of the start point of the really important code. What it's doing is setting whether this is a preview or whether this is a screen. So this function is going to either hand off to the render preview or the render screen. So there's a little more work in screen, so we're going to look at preview first. So here I'm going to go to the render preview display. Now again, the preview is that small window in the actual preferences tool that renders the view of the blanker. So here what I'm doing is setting a couple of variables, UN32, unsigned. It is probably signed, actually, after learning about the variables in the system. I can clean some of that up. I'm taking the blanker renderer width and height, and I'm setting them to just a placeholder. I could continue to reference those, but I set them to a placeholder to make it easier to read. I have my loop control, which run equals true. This is actually leftover, it doesn't need to be there, but we'll leave it in for now. I enter a while loop. I say while my run is true, I'm going to draw the background color to black. And that's what this is doing. It's basically saying for the blanker renderer RAST port, set the blanker, What it's doing is setting the pen color for the area fill, which is down here, which is using this blanker renderer RAST port, and it's starting at 00, and it's going to the length of the window, and it's setting black. So this is getting into some of the GUI work. So remember that the blanker is rendering the preview. It gave us a pointer to what size the window is. So when we create our own screen, we have to track that. We set it to black here. We then check to make sure we're not supposed to be running. Because if we're supposed to be running, we need to exit so that the blanker can release and give the system back to the user. Or maybe change the blanker module, so we need to release that area. And then we call the actual IFS function. So if I change this piece, this IFS function, if I remove that, it will no longer draw the preview. So we can actually do that just as an example. I am going to turn on the delay, because if I didn't do that, it would just spin in this loop during preview, and it would, if I didn't do that, it would spin in the loop in the preview, and it would consume unnecessary CPU cycles. Let's see if this builds. Sorry, I have a legacy from USB stick in there. Okay. So there's a couple errors I need to clean up around types. I was hoping to talk to Steve about that because he knows more about programming than I do. So now that I have the new blanker built, I'm going to copy the IFS blanker to sys utility blanker. So that's now in place. Running the blanker. So here you can see the preview. No preview. I turned off that bit of code. It's going through the loop. It's getting to that place. It's not doing anything other than an 8 microsecond delay. Actually, it's a 50th of a second delay, and then it's going back. If I hit test full screen, it should still give us the full screen. So what I'm trying to impress is that if you want to very quickly draw something on the screen, if you have a routine that draws a block or some dots or whatever, you can put it in that spot and it will just run it and do it. There are a few things you have to be mindful of in your actual loops, and that is handling the user data. So now we'll go back to the code, and I'm going to jump into that IFS function here using the quick links. And then this gets very mathematical. I do not understand the function. My level of math skill isn't high enough. I looked at it a little bit and gave up. I don't need to understand how it works because the code works. I just need to understand how to take the business end of the code, which is drawing a point, and make sure that the blanker can make that work. So as you can see at the top, we're receiving into this function called the blanker data structure, which has all of the function information and all of that. The RAST port, which in the preview case is the little window, and the full screen case is actually rendered by that piece, and it's the screen RAST port. And then the width and height of our target. So I get that information, and the reason why I get these things here is because if it's coming from preview, it's different than if it's coming from if it's a full screen. If users change the screen size, I don't know that, I have to receive that into the function. And so we take that into consideration. So looking through here, you can see our settings in here. This is our first touch of the graphic data. For example, if I change this to, I think that's enough. Let's see if that works. To all Fs, so all zeros is going to be black, and all Fs should be white. So we'll go ahead and rebuild this, copy it over again, and see the change.
Get assigned to 10. Say it's an error.
Yeah, I think I just need to quit out and load up again, but I'll just click faster next time. So here I'll copy the new blanker over. I'll run the sys refs ScreenBlanker here, click IFS. Preview is still off, and now we have a white background. So very easily I've already made a change. Maybe I'll make a randomized background and keep it, it's kind of cool looking. So we'll kill that. Bring blanker.c. Set this back to zeros because I blacked a little bit there. And then you can see here we start getting into the mathematical function. This can be anything. Anything that says, here's a point, where to put it, what color it needs to be, draw it. Here's a point, where to put it, draw it. That's a not very efficient function, but that's the way this particular algorithm renders. If you were, you could do the text functions within AmigaOS, you could do all of the drawing functions, all the glitter functions, do whatever you want here. In this particular example, it's just doing a lot of math that I really don't understand, so I can't walk through it. I know there's a lot of randomization to figure out where things go, and there's a randomization of the colors. This call is setting the color pen. And then we start getting into the business loop where it's using those parameters and it's generating where the XY coordinate of the next dot needs to go to draw the lovely pictures. Scroll down. And one important thing here, there's a utility, there's this call hook packet. This tells the ScreenBlanker to render the screen. So you put it in as part of the rendering package, the part of the rendering, it draws it to the screen. It's kind of important. If you leave it out, you just don't get anything, so you can put it in. And then this is what I was talking about is the breakout. So this goes through these iterations, it gets to this point, and it says, have I received a signal from the ScreenBlanker engine that it's time to leave? So this is a very critical piece of code, because if you don't have that, have I received the signal, you're going to get stuck in the blanker for a long time. And it might be pretty, but it's going to be a while before you get to use the machine again. So you want to be mindful of that. And depending on what you're doing, you might put that in different places. So for example, in the photo blanker I was alluding to, there's a part of it where it's actually trying to find the next blanker, the next image. And if you have a lot of files like Paul does, then you might want to exit that, because I'm running that bit of code when the user wants to take the screen back. So you have to catch that in that function too. So anytime you're actually rendering, you want to make sure you think about when am I going to receive user input to end the screen, and where I'm going to spend a lot of time doing something so that I can make it a quick effort. When I first started doing this, you'd move the mouse, it'd take like 3 seconds for the screen to come back. And I had to sort of tune how the algorithm worked and where that breakpoint was, as I understood how it worked better, to make a better experience for the user. The other thing I'll say is if you do have any kind of wait situation, you definitely want to use a small delay or a timer device or something of that nature, so you're not wasting CPU cycles. So even a delay of 5 or 6 ticks, which is about 5/50ths of a second, is enough to not take too much CPU cycle away, but also not interfere with the user waking you up. Because users tend to work in half-second time increments. They're pretty slow relative to the computer. So even if it's waiting for a couple of ticks in the loop, the user moves the mouse, that pointer gets set, that flag gets set by the blanker data, and then it comes back to, do I need to exit? No, I'll wait again. Yes, I exit. So pretty straightforward in terms of management. So I think the goal for this was to sort of walk through at a high level, a little bit about CodeBench, a little bit about the ScreenBlanker engine. As I said, Renee Olson, if I'm getting that wrong, my apologies, Renee, has a number of examples with source code, including a port of the flying toasters. So if you want to make flying bowling balls, instead of having to start from scratch, you just have to figure out how to take the toaster bitmap code and turn it into a bowling bitmap code. Much easier than having to write the thing from scratch, especially if you're getting started. If you know what you're doing, like some other folks, Alex Cremona, you can just crank one out. But if you're new to coding, it's a great way of engaging the system. You get to play with graphics, which is fun. You get to make a ScreenBlanker, which you can show off to your friends. And it gets to entertain you when you're not using your computer but sitting at your desk. It touches the GUI aspects, and whether you tackle that piece or not depends on whether you want to do it. And it allows you to get an introduction into some of the other things. The last piece I wanted to talk about was debug. So in this particular build, and this is part of the example framework that we got from Renee, debug is set to 1. So if I search for debug level here, notice that if debug is greater than 0, it will print out these messages. So if I actually open Shishimi, which I've never done this before. Nope. Steve left. Where is Shishimi?
Bill, that would have been after.
After, thank you. I knew there was a way to do this.
If you've done it before.
If I had done it before. There it goes, it worked. That's pretty cool. Okay, so now if we go back to our ScreenBlanker engine and we click on IFS, we start getting a lot of debug output. Remember how I turned off the render preview and set it to 8 ticks? It's just spewing data out the port. So if I actually hit forest, it'll stop and we get some real data. I'm going to fix that right quickly here. So I'm going to go back to my quick links. We're going to go to where was it? Render preview. Scroll down. I'm going to enable again IFS. And I'm going to turn off this DOS. Save that. For JSON, I'll try to click faster. So now I'll copy over our blanker. This is our updated blanker. Run it again. So now you can see we get a little bit of debug data. It gives us our lib base, the seg list. You can see here the debug that I put in here. So every time the IFS blanker finishes an iteration, it jumps back out to the main render preview, and then the render preview calls it again. And so that's why we're seeing this exited to IFS render preview. So that's telling us how long it's taking it to get through that mathematical function, which is drawing these couple iterations of these pretty pictures on the screen. I'll go to full screen and let that run, and then you can see here I have some additional debug entering the main rendering loop, last blanker mode, hitting the while loop, and I have some other things. The debug here isn't too special because this is relatively easy, but you can communicate to yourself what the program is doing. If I wanted to disable that output, we go to the debug command, we set debug to 1. Oh, one other thing I forgot. In the very top of this thing, of the code, there's a bunch of defines. These are the various information. So for example, this is the version number. You can bump this to .2. Scroll down a little bit more. Somewhere in here is my email address and name as part of the author. So if you just search for author, you can find that. There's a little trick to put in the compilation date with the make file that's included. If I go to project and settings, and compiler has the immediate date flag. Actually, no, I think this one's broken. I don't think I'm doing this one right. If you go to Renee's other examples, I think I used asmart as the base for this one, which is why there's some extra random numbering and stuff in there. I just took that, I took that blanker and I took the IFS one off of AmiNet, and I just started merging them together and learning how to program. Let's copy it, or ScreenBlank perhaps, put on IFS. No more output from the IFS blanker. Forest, IFS, no more output. So turn off debug, re-enable the preview, and now we have a full-on, beautiful Amiga ScreenBlanker. Do something fun with your system, learn how the system works. Flying bowling balls would be great, super easy. Just go download Flying Toasters, make the changes, get it working, and publish it. Are there any questions about sort of what we went over? What I'd like to do now is, if anyone's had to make some changes, recompile it, copy it in, try it. If anyone wants to get more advanced and has an idea for a quick ScreenBlanker, maybe we could hack through that and try to get it running. But I know it's kind of late, there's beer, but what do you guys want to do? Okay, well, thank you very much. And hopefully that was somewhat informative.
Thanks.